so at this time, I would like Roger Cohen, please get up and give his presentation so that we know and can inform the public what we are looking at in this project, because I'm not sure at this point. Thank you, Roger.
Great. Well, thank you all very much for again taking the time and having me again here to present sort of follow-up information. I will try and add to the presentation, but based on your discussion, just to make sure that I can provide you with as much information as you need and see fit. So, again, this is again sort of a status update on where we are. You've seen the slide before. This is just sort of a repeat. I think everybody in the room understands kind of what's driving the project here. So it's we've got mandated water quality requirements for returning the processed water back through the treatment plant, and so that's where that treatment process of that recycled water will take place at the plant. And again, as George mentioned, it's sort of in response to ongoing restrictions and more stringent requirements for the NPDES permit, and so we're looking at alternatives for that. For instead of discharging the water, then would be to retreat the water through the existing treatment plant.
Roger, can I interrupt you?
You sure can.
I just want to make sure you agree that the current plant, as it currently exists, without improvements, we can't meet the NPDES standards.
Well, yeah, I would agree with that statement there.
So we need, in other words, the status quo won't work. We need some kind of improvement.
From what I understand, yes. I mean, from the data that I've seen, yes, that would be correct. And then along the lines of this, I guess not to be overlooked is, this is also, in addition to processing and recycling the wash water and recycling that, there's also the residuals handling aspect of things, and so we're accomplishing an optimization, I think, of dealing with the solids, which for many plants that's as big of a problem as a lot of other facilities and a lot of other issues that facilities have. A lot of times the solids becomes one of the bigger issues that they have to deal with. And so what we're accomplishing with this, in addition to the recycling aspect, would be also to be improving the solids handling and ultimately hauling that off-site. And again, just to repeat sort of what our initial scope, when Lee and Rowe was selected and based on the original RFP for the project, we were looking at different options than what we're looking at here today. And again, I think it's been through a very active participation on staff and identifying and working with us as the engineer to understand exactly how the treatment facilities operate and what some of their unique needs are for this facility, to really sort of understand that. And at the time that the proposal came out and other engineering firms, ourselves included, proposed on it, there's always some information that you can glean from that, but it's a process of understanding that once you're selected to do the work, and then you go in and you start finding out, gee, it wasn't quite what we expected here once you get going on that. So, but again, we're looking at different options, much more, I'd say fairly simple options here, including this third one, the line basins, with and without on-site thickening. And as has been mentioned here in 2012, then we were initially authorized to move ahead with the option of looking at ponds, where the water would go up to the ponds as before and then would be returned to the plant. And basically just that. I mean, it was a fairly straightforward project. One of the slides I didn't include in here was again sort of talking about sort of what some of the discovery was, and I'm happy to answer those sorts of questions again. But really, again, it was through staff's input and kind of reviewing as we went along to then discover that, okay, yeah, gee, it isn't going to work quite as simply as we thought. And again, there's some unique aspects of the plant here, the way it's operated and the way it's been fine-tuned now. And so that's where we sort of went off, with staff's consent here to look at different options. And so I presented one option at the meeting, the board meeting here back in May. That was one option that had been devised, and that was the one that's referenced, that was just under $8 million. And after that meeting, we had some additional brainstorming here with staff, and that's where we've had come up with these three options, which are presented in the packet that I believe you have. The first option, option one, was basically stays as close to what our original scope and what our original contract was and what the original authorized project was. That would be to continue to utilize all of the ponds that you have to make the improvements to those. The one addition there would be to look at an additional equalization tank, and really what drove that was, some of the most recent plant operating data indicated that in order to meet one of those requirements that we had listed earlier, and that was the rate at which that water is returned to the plant, and that's what the whole purpose of the equalization is for, is to be able to control that water return rate, that amount of water was going to be bigger than what the ponds themselves would be able to accommodate. And so that's where option one basically stays with the ponds, but then adds that additional storage to that. I mean, the only other alternative related to that would be to make the ponds themselves bigger, but just given the geology up there, given the amount of rock and everything, that would be quite a bit more expensive, I think, than just to build an above-ground steel tank. Option two, which was really the one I'd say closest to what I presented here to the board back in May, and that was to look at a new equalization tank and then package plate settler unit. And the idea there, that would essentially replace the main function of the ponds. That is to say that you would be separating out the solids from the wash water, from the processed wash water. You'd be separating out the solids there and then treating the water to a point where that water could be recycled and returned to the head of the plant right there. And then the solids themselves, that would be this additional thickening step, and the solids themselves would still go up to the ponds because it has to have a place to go, but the ponds now serve a different function. The ponds at that point just serve the function of storing the solids, whereas in option one, it's the primary treatment process. You're trying to accomplish the water quality improvement as well as the solid storage. So, and option two then was broken up essentially into two sub-options, or would be. The first would be, as I mentioned, with 2A would be to stay with the improvements to the ponds, although in this case, we would be going just with the south ponds. And I don't know, is everybody familiar when I speak of the south ponds, what I was referring to there? So we would be essentially cutting the previous project in half and just doing improvements to some of the ponds. Option 2B would be to look at mechanical dewatering, and that would in essence take the place of the ponds in that case. So now the ponds would essentially be taken out of the equation altogether, and we'd be looking at mechanically dewatering, and you can do that through a belt filter press, which basically squeezes the thickened solids, squeezes the remaining water out so that you have a solid material that can be loaded into a truck and then hauled away. You can also, there's other equipment such as a centrifuge, which spins the water and it achieves a separation that way. But again, it's a different approach to using ponds to just let gravity and things separate things out that way. And then option three, which was I think referenced Doug in the sketch there about the PID idea, and that was this idea, for lack of a better term, I mean, I call it a custom wastewater clarification basin, because now instead of, as opposed to option two, where you would get basically a skid mounted, I mean, anything in this size isn't really off the shelf, but option two is something where it can be fabricated in the shop and then it's delivered on site in one or two pieces and assembled rather quickly. But it's more of a also, for again, lack of a better term, plug and play. You set it on site and then you work with it. The custom unit, and it's custom because of its size, and I've got a schematic here, we'll get to that here in a second, but one of the goals for that would actually be to eliminate the equalization basin altogether, because now it itself would have the capacity to treat all of that water at one time and then use it for flushing water, as opposed to having to mandate or meet that mandated 10% rule. So again, that was one that I think primarily PID staff came up with. I think it's definitely worth looking at here more closely. And again, this one we divided up into a 3A and a 3B, the same sort of difference. One utilizing the ponds for the solids, the other using the mechanical dewatering. Any questions about that? Yeah.
Roger, are you able to give just a very rough back of the envelope estimate of what the options would cost?
I have some preliminary numbers here, and again, I would say they're rough. I mean, they're kind of based on some rather quick takeoffs that we've done here, just making some, I'll say, gross estimations on the things that really drive projects. So the amount of earth that you have to dig out, the amount of concrete you have to pour, but then the next step would be to get into that in a little bit more detail and really sort of flush out some of those costs. But I do have that in an upcoming slide.
Oh, good. May I ask a question?
You sure may.
Would be option 3B, would that be on Bill's chart, or would that be your project over here?
No, it's the other side, no permit side, isn't it?
That's the PID.
Oh, it's on the.
That's the PID idea.
No, my PID is either, that's your,
No,
It's on
it's the
the
PID.
permit side.
I know
Permit side.
no, the rest side,
PID idea.
That's the PID idea.
yeah, PID.
Option 3.
But your option, no,
No.
it says here, Lee and Rowe recycle plant, is that option 3B?
That's one.
That's not 3B. That would be option, I would say ponds and EQ tank, the one in the middle of that diamond there, that's option 1.
Okay, option 1,
Yeah.
okay. And then the Lee and Rowe recycle plant would be option 2.
Yeah, I would say
Versions.
that's, yeah.
Versions of 2.
Okay, we haven't heard, we haven't listened to 3G yet, are you're doing that now?
Yes,
Okay,
yes.
perfect.
So, and again, these are the major components that go into the different options. So I've highlighted the 2 new ones here, the custom plate settler and the mechanical dewatering. But, again, the flow equalization, again, the purpose there is to be able to control the return water to meet those mandated requirements for that. The purpose there is, the water quality officials don't want water that is, from this particular source to all come back here and overwhelm the main treatment process. So that's what the purpose for the flow equalization. And that's common to, off on the right there, option 1, and then options 2A and 2B. And then along with that, we've got wash water feed pumps. We're basically changing the hydraulics here of this part of the plant. And so that would essentially be common to all of the options, 1, 2, and 3. They occur in different parts in the process, but essentially we have that. The package plate,
Roger,
you bet.
the project, the package plate settler or a plate settler, whether it's a custom plate settler or a package plate settler. Plate settler means the process by which the solids are removed from the water.
That is correct, yes.
And that leaves the water clean to a particular measure, like in this one, it says less than 2 NTUs. And I don't know what the custom plate settler returns.
Would be the same.
Yes.
The same.
Yes.
Okay.
So the package plate settler then goes along with option 2A and B.
That's that blue machine we saw, kind of a really tall machine.
Yes.
Yeah.
I don't know that I may have a picture. I think I
It was
do.
back in there, a few pictures, but yeah.
And then the custom plate settler would be 3A and B. Thickened solids, which are generated, because we're dealing with this new thickening process here, we have to have additional pumps to convey that, so that's common to options 2A and B and 3A and B. Improvements of the south ponds, again, that would be necessary still if we didn't have the mechanical thickening. And so that's where that would be common to options 1, 2A, 3A, the mechanical dewatering is 2B and 3. It's a lot of, this was a very early on schematic here. This is really what we had in the original approach. And so again, it's fairly simplified, taking the water that's generated from the plant, taking it into both the north ponds and the south ponds, and then returning that flow back to the head of the plant.
This is pretty much the one.
Well, the difference here being, one would add this equalization tank basically at this point here. So the water would flow through here, the solids would drop out and separate, and then you have an additional tank that would be located in this point to be able to control the flow back. So that's what's different. Option one, but as I mentioned before, option one is probably closest to what we originally had. Go ahead, Chief.
Please mention the price on that one, the cost. That was the two.
It's got it on the slide.
Yeah, now, this, without the EQ tank, was the 3.4 million here, was the estimate that we had in the preliminary design, the original preliminary design report. And a lot of, and I'd say one of the things, that caused that price to increase from the September 2012 meeting was, subsequent to that meeting, we had our geologists go out on site and dig around in the rock out there. And in addition to that, we discovered, some additional work that would have to be done on one of the ponds here to basically stabilize the banks. And so that's what caused that price to go up to our estimate at that point, 3.4. This one here, with the EQ tank, we had estimated just around $6 million, including if we go with the same size EQ tank, which would have been our assumption here to date. Any other questions about this one? And this was at the last presentation here back in May. And so again, a much different process. These are the package plate settler units right there. As you mentioned there, that's kind of the blue machine right there.
Yeah.
And so this is a fairly compact unit here that again is intended to separate out the solids. It's doing essentially what the ponds are doing and doing it in a more compact footprint.
Accelerated pace too.
Yes. So the residence time, and that may not mean a whole lot to most people, but in essence, you're able to, instead of having a couple of acres of ponds, you can fit something like this in a building or under a canopy, weather cover or something like that.
May I ask a question there?
Of course.
This might be a little too in-depth at this point, but if you're replacing a couple of acres of ponds with this itty-bitty coffee press over here, it sounds like the coffee press has to stay in operation frequently, like every half hour or something. You're pushing that coffee press. And if we have a breakdown there, do we have a backup coffee press, or do we just shut down filtering water until we get that fixed?
What we talked about is having backup key components, because it's not a 24, and jump in if I misrepresent what we discussed, but it's not a 24/7 operation of operating that piece of machinery. So it's a 6 to 8.
Only when we flush.
I think we guessed 6 to 8 hours a day, I think, was it?
For generating the flush water, or how this would
I think
operate?
he's talking about the filter press, which may jump into another.
Well, correct me, I understood. I understood that's what you were speaking of was that.
Yeah.
But yeah, so we're talking different things. To answer your question, Ken, the bypass for that, I mean, you're correct. Now, the maintenance on something like that generally is not that involved. And I'd say probably the biggest aspect to it is, eventually over time, you've got solids that build up not only in the bottom, but also in the plates. And so, a typical maintenance routine a couple times a year would be to actually have to hose it down. So you have to drop the water level down, hose it down. So at that time, you do take it out of service. There is the possibility that, something else may happen to it. Again, you can always speculate. But the idea here for that was, one of the purposes that the ponds then also functioned would be actually as that bypass, so that you wouldn't necessarily get the exact same level of treatment, but yeah, instead of sending the water, the water would always go through this EQ tank. Actually, I take that back. We have the option also to take it directly from the existing pumps that you have and then just convey it straight up there and run that on a short-term interim basis while there may be some.
So there's a backup program in
Yes,
place
yeah.
for mechanical too.
Now, one of the questions that, has come up too in our discussions is, if we go with the mechanical dewatering, and really one of the drivers for that is, rebuilding of those ponds is not inexpensive, as you can imagine. With the rock and then just the putting a new liner down on it, which is not presently there. The mechanical dewatering would be to eliminate the altogether. And so then the question of redundancy and backup comes in there. I guess one of our recommendations would be, even with the initial project, if we just go with one plate settler unit initially, which I think has been the intent, would be to, plan for, and by that I mean maybe leave space for a second unit in the future. You may need it, you may not need it, but you hate to build something and not leave yourself space and then wish you had done that later. That comes at fairly low cost and do that.
You would actually rough out all the equipment, electrical and piping, and just take it and set it in. The backup.
For the
second.
For the second one, yes. Yeah, anything underground.
I just help do that on an all situation.
Yeah, I would say anything underground, and especially with
Hold it
electric.
in and bolt it down and plug it in.
Roger, I think that Roger got a question.
Oh, I'm sorry, yes.
Oh, yeah, with any of these options, are there any chemicals introduced, or is it just mechanical processes for settling the existing particles?
There are standard water treatment chemicals that are presently used at the plant that would be also used for this. For instance, this process right here requires a little bit of a polymer chemical, which is presently used at the plant now. But because we're introducing that process there, you need a little bit
That
more.
makes it dirt bind and settle.
Correct, yeah, and it helps things settle out more to make that work.
Is there any kind of metal in that polymer?
Not that I'm aware of, it's primarily in
That's what
the
these things designed to take out, right? We're taking out the aluminum byproduct.
No, but the aluminum is there as a collaborator.
Okay,
But
but
in this case,
Taking out of the
I
water.
mean, you could, I guess, use that on, but typically they use polymers for this process.
we're taking out the aluminum
Out of the water, but
out of the water. That's what the plate settler's there to do, is to clean that out.
Well, it may have some effect on that. I mean, one of the benefits for recycling water is that the limits, that the water quality requirements going into drinking water are actually going to be different. Yeah, it's different from the NPDES. So we're not as concerned about that. I mean, we're not introducing anything that isn't already, from an aluminum standpoint, we aren't introducing more of that. Yeah, so again, the difference with option 2B would be, you'd be taking that step out and be replacing it with mechanical dewatering, which would be somewhere located, and that's, again, something that has to be figured out, is, where all of this would fit on site ideally. And that would be, taking that and pump it up.
Now, what you come up with here is excellent, Roger. I don't want to say anything, but it's not outstanding. You're doing a great job. It's what we paid $149, will pay $149, $105 today for you to do all this. This estimates has come up and ideas and the brainstorming and all of that. And now, when we are, if we are whatever, the next step will be to really polish that with all the engineering hookups and all that, right?
Our original contract and our original scope,
Yeah, the 2011 one.
yes, that was essentially to do this.
How did we come up with all this other stuff?
Well, and that's.
We had to pay for it, didn't we? Your fee, do we keep increasing the fee? Up till we got 140, right now, as I understand it, we paid you 100, it's here in front of us, $105,000. And your company firm can go up to 149 or whatever it is, 150,000, say, something like that, right?
Correct.
Yes.
So what will we be getting for the rest of the $40,000, $45,000?
Well, if we go with one of the options here. I mean, they're all a different project, all a different scope from what we originally had. The one that is closest, and that's where, and if you'll indulge me, I can get to those fee range numbers. But the option one would require the least amount of additional engineering. Option 3B, I believe, would require, I mean, that is, a much different project. So, and so this is a schematic that Neil had put together actually for option 3. And it's really 3A because it has the ponds up here, and again with the same idea that 3B would be to utilize mechanical dewatering instead of the ponds. And again, the idea here would be to construct a treatment unit that could handle basically the maximum instantaneous flow, which is generated at a rate of, what we determine, was it 6 MGD or okay? So I mean it's a significant flow, but we're talking much larger flow than the equalized flow, that we're sending to a plate settler. You'd have to have a whole bank of plate settlers in order to make something like that work. But so this would be to construct that in, again, what we're calling a custom design, where the equipment is still specified and provided by one of several manufacturers. That would be part of a competitive bid process. We have several manufacturers for that. But then it's installed inside of a concrete tank that would be custom, size and everything to meet the flow requirements that you have. And so in this case now you've got flows that are returned, rather than returning to the head of the plant, we're actually, the idea would be to use that for flushing. And so, again, we can use that water differently and not necessarily bound by the 10% rule for that. So same issue with the solids. I mean, we're still generating solids. We still have to deal with that.
But it's a bigger treatment process for that water, but less storage, because you're using it over and over again.
Right, so there's no 2 million gallon equalization tank for this. The water is coming in practically as fast as, it's going out practically as fast as it's coming in, and we're just dealing with it more quickly.
But actually, then some of that would be the 640 plus or minus acre feet would be just going around and going out into the system. But it's purified.
Yeah, any of these options will have the same net result, yes.
And again, I just included this in there just, for, I know you're all familiar with the site and the facility. These are the south ponds that we're speaking of. The north ponds are the ones that are off the photo there that, with all of these options, are sort of taken out of play. We're talking primarily these, just, in our estimation, that's going to work out the best. And then, you've got a fairly tight plant site there, and so, we're looking at, trying to get, these new facilities for these different options on there. Some of the options include utilizing the area down here, which I think had previously been used for solids dewatering at one time. And we've been talking about this circular tank there, which is no longer in use, and so we're talking about utilizing that space there for one of these steps, as well as some of the land here. But trying to consolidate that within the plant site instead of having to do that operation on the other side of the road and send staff off-site and such. So these were the costs that I mentioned here. At our last meeting, the number that we had, the number presenting was about $7.8 million. One of the things that we eliminated here in the decision making to get to the 3 options was the previous option had included constructing a second wash water tank next to the existing one, and that certainly accomplishes some goals here, as just based on where it's located and physically what would be required. That was also not an inexpensive project to undertake. So the latest ranges and options here we're looking at are, again, $6.15 to $7.25 million. And, these are, again, preliminary estimates, and we've got contingencies built into our numbers, just, to try and make sure we capture that, and, we don't, if there are some unanticipated items that come along, that we have a contingency in there to hopefully, get with.
The custom plate settler, that's the PID option.
That is the EID option, that's correct, yeah.
That's the last one on the sheet.
5.5 mil.
That's
5.5
correct,
mil.
yeah.
Now, that's the one, that's the total cost for that.
That is for that element, so you're either looking at, reconstructing, along with this, you're either looking at reconstructing the ponds, or you're looking at mechanical dewatering. So this, you would add either one of those two numbers, the 1.75 to the 1.
So we're gonna be around 7.25 million.
Yeah, the lowest cost option would be basically these two right here. If we go with the original project and then look at an equalization tank to that, I think that's the one that gets us at the 6.15 million. That would be option one.
Currently, the most efficient and long-term, as far as what you see from right here, to meet demands and maybe upcoming demands from the state, is going to be one of the plate settlers.
And
The 2A or 2B choice.
right, and I'm happy to go through that again here, but as we talked at the last meeting, options 2 and now options 3, and with that 2A, 2B, 3A, 3B does provide more operational flexibility. It's a more robust treatment. It does, it's going to be more consistent in terms of meeting those requirements.
3D or PID, what the guys have come up with, and plus your engineering skills, they're the options you think might be the most effective over time?
Yes, the 2A and B and 3A and B operationally, I think, will fit better with the current plant operations, and just, I'd say it would be a little bit more seamless and long-term, and also be a good long-term viable option for either one of those.
At this particular point, and maybe this is what Doug is wanting to know, would you be able to tell us what the additional engineering cost will be for the option 1, and then the option 2A and 2B is option 3A, 3B? Is that what this is?
Yes, and what
I think that's what you were
I don't
right.
know if this is,
Yeah.
let me just cover this real quick, and then I'll get to the other one, which has all the numbers. But the additional scope that we've discussed with George and his staff, it basically boils down to the two main tasks. The first would be the preliminary evaluation would be to look at these options in greater detail. We've already spent some amount of time there looking at them. We would continue to fine tune them, and now that we've kind of distilled it down to these 3 options, we really focus on these and evaluate them both from a costing standpoint, also from an operations standpoint, and then come up with a recommended solution for that. So we have this preliminary design. We also have some additional field work from our geotechnical stuff to go out and look at where the areas on site here that we would possibly be looking at these new facilities. So far, the work that we've done was all up at the pond area, since that's where the work was conducted before. So that was this $113,000 for that work, again, including the field work. And so that's, I'll say a fixed cost, because it's a well-defined cost. I mean, we know here's what we're going to look at, here's what we're going to evaluate, here's what we're going to come up with. Task 2, obviously, is the final design, and that's the one that has the range. It varies by whichever the option was. I'm sorry, I just realized you had a question. I apologize.
Do you, in these final figures, have you considered the trees, the trees that are protected up there by those ponds? Have you, in light of the knowledge, did you know about those before I mentioned?
I I would say, yeah, no, we would have to look at that here more closely.
Okay, so-
We haven't fully-
Would you imagine that those trees and the fact that there's serpentine there with asbestos in it, would you imagine that that would drive the price up?
Well, we certainly accounted for the serpentine element to that. I mean, that's gone into, that's also helped on the, I should say, led to some of the earlier increases in the site work for some of the earlier estimates that we had. We would have to look into the issue of the trees here in terms of, and I would think part of that depends on, where the new facilities are going to be located. If we're constructing them in areas where there are already facilities or there's nothing there, then the impact of that may be minimal to none. So that's something that will have to be looked at here more closely. So for the task 2, for the final design, that's where we've got this wide range, 85,000 plus the 362,000 for the final design. And so the upper limit, which, again, was the number that was the upper limit number that I think was presented here, was the sum of the task 1 and the highest task 2. Understanding that, if the alternative, if the selected option is not option 3B or is the most expensive one, then we would adjust our engineering effort here to match that effort. So these are slightly different numbers, and I put these together as what I called engineering fee metrics, because obviously, we're talking a lot of money, we understand that, and so I think it helps, to understand kind of the way, from the engineering standpoint, a lot of the questions that we get and sort of the way that we look at things. But maybe before I leave your question, Seth, the estimates for the different design options are presented in that table on the last page which has all of the different breakdown. So that does have the amended engineering effort, which ranged from the 85,000 again to the 362.
I just want to write some estimated totals next to the side of those.
Okay.
So now we got 6 on the first one.
Well, again, these numbers are slightly different, and the reason why they're different is I offer this up as kind of a comparison for the different projects. And so one of the things to note here is that task 1 cost has been taken out, but it does include what our original design fee. I mean, our contract is split up in the same sort of way that we're proposing here. There's a task 1 and a task 2. And so two of the metrics that we find, and probably most meaningful in our discussion with agencies, is how does our engineering fee relate to the estimated construction cost, and how does the engineering relate to the size of the deliverable, and we a lot of times measure that by the number of drawings. And so obviously, if you've got a set of plans that's this thick, it's going to be less engineering than if it's this thick. Yeah, Bill.
Did you bring copies of that chart there with you? Or can we get copies of it?
I can certainly provide that.
Yeah, I
Can be
can
printed out.
I'll email tomorrow.
Yeah,
I remember the last
that would be
time.
nice, but we don't have them.
The last time we had exactly your presentation,
Okay,
this was here, are we going to be able to get that again?
that should be no problem.
That'd be-
That's right, I think I emailed it to you afterwards. and we can do that. And so, again, what it shows, or what I was intending to show with this is, again, kind of how the project stacks up, both, from our original project and what these different options are. And there's no one magic number, there's no, where we always shoot for a set number. We look at this in fairly good detail here, what we think. We do a detailed sheet count for each of these, where we say, okay, if it was project 3A or 3B, we're going to have a building, and we're going to have this many drawings for the building. We're going to have probably an architectural drawing for this, but we're going to have more structural. One of the things I know that was mentioned, Bill, perhaps you had, was about tanks, and about steel tanks versus concrete tanks. And there's a difference in the engineering for that. There's also a difference in the initial capital cost. There's also a difference in the maintenance cost for that. And those are all of the trade-offs that we look at here when we come up with that sort of a recommendation. Generally, designing something out of concrete, there's more of a structural effort for that, and so that's gonna be more engineering than a steel tank where the manufacturers actually do a lot of the engineering for you. You just have to specify, I want it this big, I want it to hold this many gallons, and they kind of do the rest, so. But what it shows is that, you know, there isn't that much variability in terms of, you know, both in terms of the engineering effort, both when you look at it in terms of percent of construction or engineering cost for drawing, and sometimes they flip-flop. For instance, 2B and 3B with the mechanical dewatering, it's a higher percentage of cost, mainly because its construction cost is a little bit lower. So you look at that and you think, well, gee, that seems a little bit higher. But when you look at the cost per sheet, because we're generating more sheets to do that, that metric for that actually shows it being slightly less. But, you know, they're all fairly close, and again, a lot of it's dictated both by the estimated construction cost and then the effort to do it.
This is actually for George. Can we get this on the internet, our internet page, and tell the public that we have this within the look at?
Sure.
That will help with a great deal. Thank you.
George, I have a question for you also, if I may. I didn't cut off, did I? It sounds like unless we're willing to spend $1,276,000 in just engineering fees, before he gets too much further down the road, the board is going to have to come back here and select which of the options, 1, 2A, 2B, 3A, 3D, we want to proceed with. Is that correct?
Yes.
Okay. And what type of additional information is going to be presented to the board before we make that determination?
A more fine-tuned cost analysis and a more fine-tuned operational analysis of which option we think will operate best.
And longest and least time.
And if I make a suggestion to Bill back one slide, Roger, one action you can take tonight is authorizing a contract amendment to obtain task 1.
To do what?
To do task 1 for the $114,000.
Which doesn't include the final set of plans.
Yeah, it's not final design on anything, but it's gonna fine
give us all our
tune all of
numbers.
our options, and you'll have a better comparison to actually choose which one to go forward.
That's, okay. The $113,000 is not part of your $149,000 contract.
That's correct.
That's an amendment to it.
That would be an amendment to it. So what we would be doing is amending to pay you an additional $113,000 to fine tune.
Well, that takes us to our next step.
Preliminary
I mean, there's surveying for these additional options. there's
Oh,
tech
so
investigation.
actually, out of that $113,000, you have surveyors up there surveying and running grade and all of the other stuff necessary for contract.
Yes.
For you to do the engineering for the contractor, you come in and do it.
I think the long and short of it is we're going to be able to tell which one of the projects with the additional 113,000, we'll be able to tell which one of the projects probably best suits us budget-wise, academically, be able to put on the ground, I mean, just be able to build it. You know, there's a lot of problems that I see.
Some of them-
ponds where mechanically dewatering, it just seems smart, get away from those ponds and let them be for the rest of all time.
Like
So-
Lauren mentioned, anything on the endangered species or any of this would come out of that type of time, you know, because I don't know if there's any, I don't know, if you're thinking of the dab cypress, I'm not sure how it, dab cypress is.
Because they're not looking at stone on the pond area, so.
You'll have construction equipment though around there, and that'll cause, those are state protected, they're even federally protected, as I recall.
Everything is.
This is what we have to look at.
Let me remind you,
You've got a sequence
you
there.
got a secret
Yeah,
process.
secret
Yeah.
Fleetwood takes care of it all.
Okay.
So Ken, that's another opportunity that the board has to review this project, is during the CEQA process. You know,
See, that's why
presented
it's
with-
going to take a long time.
So to keep us moving forward, I want a clarification, is that 113 in addition to the 1, or 5 that's expended, or in addition to the 149 that's been approved?
Well, we can do that either way. I mean, I guess the way we had calculated the task 2 cost was to take that remaining, what's in our remaining contract and move that into design. If we want to use the rest of that for the preliminary design, then it would essentially be the difference. So it would be the 113 minus what's remaining on our contract to basically come up with a preliminary design, and then essentially some of the task 2 numbers would change because the task 2 numbers took that remaining number and kind of backed it into that, so maybe we can.
Is
kind of
this
move
a
it
fixed,
I
not
noticed
to
here-
exceed number?
On this one, I was reading this much earlier. You have a 1 on 2B and 1 on 3B, which includes a $75,000 credit for remaining design budget towards mechanical and water.
Yes.
So you're going to give us a $75,000 credit for this design?
Yes, I mean, because those options, I mean, if we went with an option that included the ponds, and for which we were already under contract for you to design those improvements, we wouldn't, there's really no change in that design element to it, so we wouldn't ask for an extra on that. For the mechanical dewatering's a different project altogether, and so the way we calculated that, we calculated, okay, here's what it would cost to design that, and then took the remaining design and backed that out.
Yeah, then we $75,000 back down. You know, what George was saying, if we move the min, which he says up here, so on the top, to this 113,000, you wouldn't put 113,000 plus whatever's left, 40,000 that we owe you on the budget, right? That 40,000 would be, come off the 113, is that what you were saying?
That's what I'm asking.
That's what you're asking.
It's, so, I mean, I guess the short answer is, yes, we can take the remaining money and, I mean, if we can change this amended amount to do that.
So in other words, your presentation this evening is getting here and all of the above is going to be billed out of our 140, what's left of that $40,000 thing.
Well,
Because we've already paid 105.
yes,
So any other bill, any other charges that you've accumulated, including tonight's presentation? will be
exactly 105?
$105, $877.
We paid you 105,000, so
From this first right here.
for all these things that you've done, and this nice new packet for
Yeah, that's your number.
now, and just so that we're clear too, the 113,698 actually, I mean, it includes some of the work that we've already done that I think is reflected in that 105. So again, we can, I guess what the final amendment number, the way we calculated, we said if we froze all of the remaining money, what's in our contract, and preserve that to finish the design. And so starting, you know, from this moment, if it moved on to the preliminary design, or, you know, under this task 1 amended scope,
Yeah.
it would be the 113,698. But if we want to take that money that's set aside for design and move that in, then that amount would be lower, that amended
Well,
amount.
with this preliminary design, and I think George said that pretty well, what you're gonna come up with would be some facts and figures and design that would help us decide as a staff, which one would be best for us to take, that point to staff.
Yes, that is correct, yes.
Closer to the goal.
Yes.
Um,
We keep moving forward.
It might be inside the 20-yard line before the end of 2013.
I would like some explanation. One of the people in the audience said it started at 2.2 and now it's at 8 to 10 million. Now, where did that information come from?
I think that was Doug's.
Was that Doug saying it was
On September 19th,
Those
you
were some of the
voted
numbers.
for 2.89 million,
Yeah.
right here. I was out there in the audience, and when we took a break, I charged over and said, how in the hell are we gonna pay for it? And you said, we're gonna go for a rate increase.
Not me.
Yeah, you
I
guys
never said that.
Well, anyway, whatever.
That could have been me.
That could have
It could have
been,
been,
Then the next time we heard that, Larry, it was 8 million, right out of his mouth. See, and there was no explanation why it went from 2.89, and everybody, including Jim and people that had bought in, George, had bought into option one for $2.89 million construction. And I went right up there the next week, and Jim gave me a phenomenal tour, and we looked at what they were going to be doing for the 2.89. And then the next time I heard about it, after I was on the board, it was 8 million. That's
So
what
I think Roger
So
did
my-
say when he said the 8 million, I think he said, we could go in the vast scope of projects that we could choose here, that we could go from 2.8 million to 7.9.
Yeah, it's on his-
He did say that, but that was in the vast scope of things that we could choose. Not, we have a choice of 2.8, but you know what, we just kind of threw that one away, and now we're at 7.8. That's our range, which he's showing us to us tonight.
So can you tell us,
What time?
here, this is what the public wants to know, why did it go from 2.8 to 7 million or 8 million or whatever?
That was what he presented
No,
last time.
Different.
Very.
Yeah, but what,
That's why he came last time.
I can understand from some of the research that I personally done on this thing, and the presentation tonight and looking at some of this other stuff, I can understand why it's come to 8.
well, I
I
understand.
say it's gonna be 10 before it's done.
But what I want to do is explain this to the public.
It's only an
That's
act,
what
you
we gotta
choose
do.
that choice.
Okay, now I'm gonna
Dustin, I'd like,
Mr. Chairman.
Dustin has a,
I have a question. This is the 113,698. That's time and materials not to exceed that price?
We would, yes.
Is that what your proposal is? Okay. Just want to make sure. If I'm passed, so what that means, if I'm passed with writing a contract amendment, they're going to bill against that amount on a time and materials basis, but in no event will it exceed that amount.
Why don't we do
she's
that?
at 40 that's left, and
Okay.
it's going to
I'm-
40,000.
Okay, I want to make the motion. I move to amend the contract from the original amount up to $219,575.82, which is adding what they've already been paid to $113,698.
And I'll second that.
$219,575.82,
That's not to exceed in your mind?
not to exceed.
Not to exceed.
The,
That takes your 40 out of your
That's
frozen.
shut in the form.
And including it in there.
yeah, no, that would, I mean, that would be fine for us.
Call for the question.
And that
Need a
is
second.
$105,000 we've already
Did you
spent.
second?
No, that's where he came up with the
What's the
Plus
218.
the 113,698.
Did you second?
Yes,
Yeah, I second that.
I'm sorry. Sorry.
I was gonna make the motion, but Larry, which is good, I'm happy to do it.
Director Hunter, you're saying? Sorry.
Yeah, the expenditure of these funds, the $105,877.82 that we've already spent, plus an allocation of a sum not to exceed $113,698, will get us a presentation from you that is going to allow us the opportunity to make a decision on whether we're going to proceed with option 1, 2A or 2B, or 3A or 3B. And that's as far as we get along on that. And information. And when do you expect that we'll get that information back?
We estimated from, I guess, when we, I mean, we can start working right away, especially if we're working within our existing contract initially. 4 to 5 months is what we had estimated. for
That long before we make a decision?
Well, that gives us time to figure out where to get the money.
And we can do that easy. You can educate the public.
Well, you were on the same committee.
This is why
We can take this, oh, let me, I can take this right now and talk, in fact, I'm talking to someone here right now, and say that the state is mandating that we do this wastewater deal, and whatever we call it, and it's going to cost us someplace between 6.1 or, and I got those figures,
6 million to
6.1 million or whatever it was, to 8 million, and I'm gonna tell people $6 to $10 million could be the problem. You know, and we can start selling that right now.
And additionally, are you going to?
Is there any more comment from the public?
Yes.
Thank you, Rob.
There's 3 ways we can do that.
Doug, actually, I've got a comment.
Go ahead and finish.
Oh, no. There's 3 ways that we can do that, and I've got this information from Kevin and George. The first way We got 10,500 meters, and you've heard me say this before.
Doug,
A rate increase.
that has nothing to do with the.
No, it's the rate increase.
I know, but it's not,
That's not what we're gonna decide on that.
it's not on the
The
agenda.
public will find out how we're gonna.
I stand corrected.
Okay, it's not on the agenda.
I stand corrected.
Well, I just have a few questions. There may be a little outside the box or comments, but one is about water quality. We think we have very good water quality here. And I don't think anything we do would make the water quality not acceptable to the government. They do change their regulations from time to time, and usually it's more stringent. So we don't know what they're going to do next as they find out how, chemicals affect us. So there's no getting out of that. This process is recycling. I like recycling. That's all good. It's taking additional sediments out. That's good. That they're going to be going somewhere else, not so good. Where is that, and what do they do with it there? But
Same place.
It's the same.
It's going to Neil Road landfill.
It goes to Neil Road
As it
landfill?
currently is right now.
Okay, so we're just saying some more, that won't be going into the environment. And at the same time, we're adding more chemicals for the secondary process during the recycling. So the basic question is, what is it going to do to the water quality compared to what we have now? Either 1, 2, or 3.
Doesn't change
It
the
doesn't
water
have
quality.
anything to do with our
It
existing water.
it changes the water that we,
The flush
what
water.
we do with the flush water.
Yeah, I understand that, but you're adding, you're recycling water, so you're.
We put it back to the treatment plant and retreat it.
Yeah.
So it doesn't, so it's
It'll be probably
treated
cleaner water that's coming in from the lake.
Sometimes it's cleaner than what we're treating raw, sometimes it's not.
I mean,
Confident you won't taste the difference.
I'll say the standard answer is, and that's part of what makes all of this expensive is that, we're treating it to meet a certain standard. And so, whatever option that we go with here would be designed to meet and exceed what the federal and state standards are for that.
Understood.
Here.
And then, and I think it's.
But like Larry said, in most cases, that's better than most bottled water that's out there.
But my question is, what's it going to do to our water quality compared to what we have right now?
No,
Yeah,
no change.
I would say minimal, if any change.
Minimal in which direction?
That question will be addressed in the sequel process. Water quality.
It's not going to higher our water quality.
Robin, there's a man right behind you who runs the water treatment plant, and he's an expert. And he's now wishing I hadn't come to the meeting, but he can answer your question.
Well, I can share with you the numbers we have, not off the top of my head at this moment, but the amounts we're discharging are very low. Okay, in terms of the THM, like Roger said, it's an insignificant impact back into our drinking water.
THM?
Okay, the THM is the dichlorobromomethane, and the aluminum, which we have none in our raw water, that'll be a very small amount we'll be getting into our drinking water.
Yeah.
The limit is 1,000. It's very low. I don't want to talk a lot about it. Roger's not far off by saying it's insignificant. That's small impact. I can get those numbers in a very simple table for you at my office. We have those readily available. Their numbers are actually in all of the grants that we're applying for right now. Those figures are included.
Okay. And then my other question is about, did Lee and Rowe come in after the other alternatives were briefly considered, the two other processes, disinfection with UV and ozonation? Was your company in on that discussion, and is it qualified to give estimates on such processes?
We were informed of some of the earlier analyses that I think staff had done to look at that. And I think it was through, I guess, this revised scope here was just to focus on the three alternatives, which didn't include
Because
that.
when you come back, I'm gonna be here again, and I'm gonna be asking about ozonation and not using aluminum. So, those are the kinds of things that I would like to have cost estimate into, just so you know. I have a
Well, I don't
question.
think that's in the scope of what we're asking for.
Not the
Right.
engineer.
Right,
Correct.
but after you spend $200,000, I'll still be back asking that question, so.
But, fair question. I think we already did some early evaluation of those.
I share.
Okay. So you have some numbers from George on the early evaluations of what those.
Yeah, and so we can compare that with when he comes back next.
Good, okay.
Can I ask Rob a question? Rob, have you taken the opportunity to go on the tour that?
Yes, a couple times.
Yeah, and you went through I did this last year because of running for office, and I still remember, it was excellent, and the water treatment plant was just highlighted.
Yeah, I've been in the.
Robin's been with us for a while here before I was here, so.
Yeah, good.
I'd like to do it again, it's fun.
This fall.
Coming up,
on the
we're
bus
here.
load,
Is there another question?
Yes, if I may have a question. I just like to clarify the aluminum to iron-based product. You talked about that, correct? That the aluminum was going to be kind of eliminated, and, right, from the water and then into an iron product, an iron-based product? Is
Well,
right?
that's one of the other alternatives that I think was referenced, and we were aware that, staff has looked at that here initially. We haven't looked at that in any great detail, and our scope here wasn't to look at that in any more detail than that. But yeah, no, I'm aware that that's been looked at here by staff earlier.
I'm sure Roger's going to have a very comprehensive analysis of the different choices for us at that time. When he comes back, 4 to 5 months. So. Did you have one more question?
I have a question. George, can you tell us where we're at in our MPDES permit cycle? One of the objectives indicated that you'd try and eliminate that permit renewal by 2015. Does that mean we're 3 years into this 5-year cycle?
Yes.
Or so are we 3 years into knowing we have this problem, or are we 2 years away from understanding that we'll be having a problem?
We are,
It's a good
to
question.
go back, when the permit was renewed, I was the one that figured out we had a problem. And brought that to the board, and that's what started the process. And Roger's been with us a year and a half.
Over 2
We've
years.
been almost 2 years we've been dealing with this. And we never banked on it, but we're told if we're making a very significant effort, like going to construction, then there's potential opportunities for a short-term extension of that until our improvements are completed.
But we will be non-compliant at the end of our permit. No two ways about it.
Mr. President, I'd like to have on our next regular meeting agenda an informational item where we can discuss how to develop a rate.
John,
The Finance Committee.
we're still on a motion.
Oh, okay, good. But I'm waiting. Oh.
Ready?
Yes.
Okay.
Oh, I'm sorry.
Roll call.
I have one more.
Okay, I'm sorry.
Council asked of Lee and Rowe whether or not our plant could be fixed to meet NPDES requirements. Is that, it seems like, I'm hoping somebody else has made that estimation other than Lee and Rowe, who's in position to gain from a decision we may hear about.
I think he was asking them to confirm what staff was already providing.
So you, George, had indicated that we're out of compliance, or we're soon going to be out of compliance, and your staff has looked at the plant and identify that there's just no way we can meet.
A couple of things really quick. The ponds will have to be reconstructed regardless, so that's whatever that cost was. And the other alternatives we talked about and looked at was ozone and then changing from an alum product to an iron product.
Or
And
UV.
or UV. UV was evaluated also.
Very expensive.
One of the big things, it's a big expense, but you still have a permit. And that leaves you with what's the next thing you're going to have to try and do.
Plus, we're gaining 640 acre feet by recycling the water, which in my mind is substantial. Okay, that's,
It's 1/10 of our, close to our normal use.
Cost
Our normal year of use.
it's a drought supply project in and of itself, really.
It really is. That's why I'm all here.
Okay.
Another tank.
Anybody else? Last chance. Any comments? Georgiana, roll call vote, please.
Director Foster?
Yes.
Director Hunt?
Yes.
Director Kellogg?
Yes.
Director Duncan?
Yes.
President Crowell?
Yes. Passes 5-0. Okay, we look forward to Roger coming back here in 4 to 5 months when he's got this. If you need to talk to us before then, feel free.
Roger, there's a $9 error in that.
There is
Presentation.
saw here and there, I saw that too, yeah. 78 to 87, yes. I wasn't done. I'm just telling Roger thank you at this point.
And I just want to thank all of you for your continued support and trust in us, and we look forward to continuing to work and develop these options forward. So thank you very much.
Thank you again. Okay, that will conclude our new business, and we're going to go on to the director's comments. I'm going to start with Director Duncan.
I think one thing I learned today was that the public doesn't understand at all what we're doing. And I don't know how to tell them. Because the things we were told that we've done wrong, I think are great accomplishments.
Director Kellogg.
I think if we work at it, and we get the public to the point where they understand what we're about, and what the advantages are, the disadvantages, and get them to the point where they'll probably be able to vote for a increase in water rates. And we've got 4 or 5 months to do it, so I think we work hard, and unfortunately, Jim and I are going to have to work on the same committee to get it done.
That's unfortunate.
Thank you, Director Kellogg. Director Hunt.
I have no.
Thank you, Director Hunt. Director Fletcher.
I have two. One is, I got head of the cart for the vote to come in. I would like to have on the next month's regular meeting agenda an informational item where we can discuss how we go about a rate adjustment. That was done that.
Oh, it's done? Okay.
So that was just for educational interest because, and I think it would be good. And the second thing, even though we had some other things, I think we were very productive meeting.
Thank you, Director Fletcher. And I'd like just to say that these are tough decisions. I wish that the public could know everything that we do here, but it doesn't always work out that way, that they get all the pieces of information. But we have tough decisions ahead of us, and I don't think they're going to get any easier. And a lot of these decisions also cannot wait for time-sensitive issues. So I'm glad we came to at least some way to move forward tonight. I think that was very productive. So thank you all for coming. We're adjourned.